Hello. Good evening. My name is Tracy Metz. I'm the director of the John Adams Institute, and I'm also your moderator this evening. A special word of welcome to our two guest speakers, David Eicher and André Kuipers. You'll hear more from both of them this evening, and a little bit more from me. And of course, there'll be an opportunity for you to ask all your questions. There's a microphone here in the middle. I wanted to begin by telling you why when we decided to do this evening with Eicher and André Kuipers, I jumped on it. I said, that's for me. I'm going to be the moderator. And why? Well, there are three good reasons, and I wanted to tell you because it might color your perception of the evening. I have a vested interest in this evening. To begin with, I was born on Edwards Air Force Base in California. Oh, there are people to whom that means something. When I told David and André, they said, oh, Edwards. I thought nobody had ever heard of Edwards Air Force Base. Edwards was the place where the hot jocks, the hot young pilots, first broke the sound barrier and then later went on to develop the space industry. And it was later where the space shuttle landed after its space flights, because there are these huge, long salt flats, endless runways where heavy machinery like the space shuttle can run its course. So Edwards Air Force Base has played a really important role in the history of aviation and the history of the space industry. And I was sort of part of it as a little baby. The second reason I wanted to mention this also is that I was born there because my father worked in navigation in the war for the Army Air Corps. Then he went back to college in California on the GI Bill. And if you used the GI Bill, you had to repay your scholarship with another few years of service. So he went back to Edwards Air Force Base, which is why I was born there. And then later, when I had to go to school, because there was no school at the Air Force Base, we moved to Los Angeles, and he went to work as a rocket scientist, as a fuel expert in Jet Propulsion Laboratory. So when anybody says, well, it's not rocket science, I say, hey, wait, I know what rocket science is. And the third reason I really wanted to be part of this evening is because I have such vivid memories of that moment when my father came home from work with the very first photographs of the surface of the moon. Oh, that sense of wonderment as a child, that sitting at the kitchen table looking at these photographs, and I couldn't tell, are these bumps or are these craters? No, no, sweetheart, they're craters, but they look like bumps. No, that's just an optical illusion, they're craters. The moon is full of craters. And the feeling of amazement that something as far away as the moon was here in some sort of tangible form on the kitchen table for me to touch and to look at. And I guess ever since then, the whole story of the space race and the space industry and the funny dichotomy of the space world that was born out of Cold War fear and military competition, and at the same time managed to become a symbol of optimism and progress and the we can spirit under Kennedy. And that all of that could be brought together, all those contradictions in that same national push towards something unknown, something exciting, the sense of exploration. And I'm really curious to hear from our speakers this evening whether they think that that sense of optimism and empowerment is something that we can still have now in the US. I don't know if they have the answer, but it's something I wonder. So that's why I wanted to be part of this evening. I'm so glad you're here. David Eicher is, for 36 years now, has been the editor of the Astronomy. And for that reason, he lives in Wisconsin. And I have to tell you, he just arrived this morning from Wisconsin through Chicago, through Heathrow to Amsterdam. So if at some moment he's sort of lost for words, please forgive him. It's just the jet lag that's coming by as a piece of mist through his brain, and he'll recover. We're going to keep the adrenaline high, David, so that you won't fall asleep on us in the middle of the conversation. David also has some amazing extra facets to his personality. He is also an expert in the history of the Civil War. I'm going to ask him why. What is so interesting about the Civil War compared to galaxies and the Milky Way? He's written 8 books about the Civil War. And this is really special for this evening. He is also particularly interested in manuscripts and autographs, and he has a big collection. And one of the people in his collection of autographs and manuscripts is John Adams. Isn't that amazing? So I'm going to leave you with this cliffhanger. We'll hear later from him about galaxies, about the moon, about John Adams, and about anything else he wants to talk about with us, together with his interlocutor, who is, of course, our very own national Dutch astronaut, André Kuipers. André, yes, we're so glad you're here. Welcome. So before I hand the floor over to David for his talk, just a brief word about this evening's schedule. When I am finally done, David will give a talk of about 25 minutes, and then I'll have a conversation with him for, say, 10 minutes, and then we're going to do something special. We have the very first showing ever of an amateur movie made of the launch of the Apollo 11 by a Dutchman, and he's here with us. And his name is Krijn Reitsma. He's sitting right here. And he was a guest. He was studying in the US then, and he was a guest at the launch. And he made, what was it called, Krijn? A Super 8? A Super 8 movie of the launch. And while we show it to you, he's never shown it before in public. I'll have a conversation with him about what it was like being part of this historical event. And then André will give a short talk, and then André and David will have a conversation with me and with you, and then we will all go outside to buy and have signed this gorgeous book, which has been published on the occasion of 50 years moon landing already. Another historic moment that has been marked by the publication of this wonderful book. And what's special about it, if you haven't seen it yet, has anybody seen it yet? Okay, just a couple. What's special about it is that it is almost completely composed not only of articles, but also of stereoscopic, stereo, I'll get there eventually, of stereo photos. And there's a little plastic glass in the back of the book, and you can look through the glass at all the photos, and then they come up in their full 3D power. And this was all made possible by the London Stereoscopic Society, Robin? Company. The publisher is here also, Robin Rees of the London Stereoscopic Company, which is an enterprise founded and fueled by Brian May, who is an astrophysicist, but whose name you may also know as the guitarist of Queen. So, with no further ado, I think I've impressed on you how special and how fun and how historic this evening is, and I would like to give the floor to David Eicher.
Thank you so much, and thank you for having me here. And I'm going to move over right away, and can you still hear me? How are you as energized as I am tonight? See if they buy that one. Okay, well, tonight I'd like to talk about a few things, and I'll keep things moving because, as you heard, we have a tremendous variety of material to cover here, which is an exciting problem to have. I'd like to talk a little bit about Mission Moon 3D, and it's a real honor for me in many ways to be here at the to be at a talk sponsored by and established by the John Adams Institute for reasons that I'll talk about a little later. But as you heard, this book project that I will share a little bit about with you tonight resulted from can you see? Yes, you can. It's there. Look at that. Well, Brian May was busily, you may know this story, forgive me if you do. Can you all hear me okay? Okay. You may know about this, and forgive me if you do, but Brian May was innocently working away in 1970 down in Tenerife on his dissertation, his PhD dissertation, studying dust in the plane of the solar system to become an astrophysicist. And there's actually been a movie, believe it or not, made about this recently. And then something else got in the way at the first juncture, to the surprise of his family, but it all worked out okay. Well, long story short, Brian is still very, very interested in scientific pursuits, in astronomy, in space exploration, in stereophotography, which he discovered as a child because of cereal. Does anyone eat breakfast who's here? Good. You still with me? Well, there's a cereal that's still around, I believe. It's called Weetabix. And in the old days in England, some of you, I think, have recognized it, they would put stereo cards into Weetabix, which you could get, and to Brian's amazement as a child growing up, see the world, whether it be the pyramids or other wonders in the world, in 3D. By having these images that are shot slightly differently and merging them together, either with a viewer, as we have in this book, Brian's own light owl viewer that he created, that is in the back of this book, or if you sort of relax your eyes, not cross your eyes, but if you focus your eyes such that you're almost looking through these images, you can kind of adjust yourself and get used to seeing them and merging them together and see them in 3D. So, what we have here is Charlie Duke on the surface of the moon during Apollo 16, and it was Charlie in the project of this book, putting this together. Charlie wrote a foreword for us, and Jim Lovell wrote an afterword for us in this book. Charlie said, this book, and this is no responsibility of mine because Brian and his team did these magnificent images. This is the closest thing you'll ever get to walking on the moon. It's really incredible stuff. You see the depth and the dimension of far distant objects, of mountain ranges, of close-up objects like the spacecraft, the LEM, the rovers, the astronauts, sticking out in the foreground. It's really quite something to see. So, Brian at one point said with a group of his collaborators, Robin and others, well, we really should do, and with a common friend whose name is Glenn Smith, who I believe is here tonight, who said, you guys should really do a book because the Apollo 11 50th anniversary is coming up and nobody's ever done a stereo book on the Apollo program and the space race. Because remember, the Soviets also had a very energetic lunar program that was moving forward that for a variety of reasons, not the least of which was early success with Apollo eventually, but also, unfortunately, the key sad deaths of some of the engineers and other key personnel on the Soviet side, that program petered out. But this space race, from its origin, which we'll look at here, was really a race to get to the moon and land on the moon. And this was a project that was fueled by that anniversary. So let's just kind of walk through these slides. We have a lot to cover tonight, but let's look at a little bit of these slides. And if you get the book, you can see them in stereo. But obviously, I won't try to get you to blink or do anything fancy here in the audience. But of course, the space race, shockingly, in the United States, where I live, or I like to call it these days the former United States, but that's another talk. It was a shock, of course, then when suddenly Yuri Gagarin took a 108-minute flight and orbited Earth and shockingly took a huge lead in the so-called Cold War space race. Well, that followed Sputnik 1, of course, that was the first satellite to go up and to produce a ping and to be orbiting Earth a few years earlier. And that produced a major set of shock waves and, you know, generals running around and wondering if that would lead to dropping bombs from space onto the planet and all kinds of crazy things as well. That really triggered a panic in the United States and a dominance for the Soviet Union that lasted a long, long time in the space race. And it spurred John Kennedy, which really, you know, a lot of us have admired John Kennedy as a politician and a lot of the things that he did. But this, of course, was a reaction. It was a political race that was born of fear. And that really made us get to the moon. And so what we do in this book is really tell the whole story of this era and the space race as it unfolded. That race also briefly included non-humans as well in a variety of ways, probably the most famous of whom was Laika, the Russian dog, a stray dog found on the street and sacrificed for the early experimentation of Soviet space technology. And of course, Laika died sadly in orbit, but that was a part of the Soviet space program moving forward as well. So just to backtrack for 1 second, we have in this book for the first time, and it's quite amazing to me that Brian and his collaborators produced more than 150 of these images, nearly all of which didn't exist before in stereo 3D, so that you can see these in their actual dimensional state, if you will. Well, how can that be, you may ask? To be completely honest, a couple of the most iconic ones were sort of fudged, but only a couple. Because the astronauts really weren't trained properly to take stereo photos. They took one stereo close-up camera to the lunar surface once Apollo missions landed, but it was a stereo camera that was designed specifically to take very, very small patches of lunar soil or regolith to show the texture of the powdery lunar soil. Images were made with that. However, in their unabashed rush to create lots and lots of images, the Apollo astronauts, once they got to the moon, shot images all over the place. And if you take images that were shot a short distance from each other, whether it be standing on the lunar surface, whether it be from a moving spacecraft, or of moving bodies in the near solar system, often you can find a pair through meticulous research, put these together and show them in stereo, and that's what Brian and his team did. This is, of course, the Friendship 7. It's actually a replica here of the Friendship 7, but showing how the American space program with Mercury and then eventually Gemini took real forward steps in complexity. Then another friend of ours at which the event at which this project was born, the Starmus Festival, some of which you may have heard of as well, and another one of those is coming up this summer in Switzerland. Great festivals of science and music and enjoying the intellect of those who are on the planet doing projects and having fun. This is where this project sort of came forth. One of those who's really integrally involved with Starmus and has been from the beginning is Alexei Leonov, the Soviet cosmonaut. He's getting up there in age now, but is still around and okay. This is a stereo image showing Alexei in 1965 doing the first human spacewalk. And this was a very, very dangerous, brave moment for him, because no one can predict, of course, exactly what is going to happen in some ways, engineering-wise and so on, when space exploration takes place. And it turns out that the pressure in Alexei's spacesuit made it expand, and he could barely get himself back into the spacecraft. So that was nearly very dangerous. Just to walk through these a little more quickly here, we now have a stereo image of a Gemini craft, which was a two-person craft, of course, that the Americans created. We also now have, this is a stereo view of Gemini 7, and we're showing now some of the testing that happened in Earth orbit. When we got up to the early Apollo flights, they were full tests, some of them now in Earth orbit. This is Apollo 9, the LEM, that would eventually land on the moon with 11. But this was an orbital test of the LEM in Earth orbit with Apollo 9. Now we have another image that's really kind of historic. This is the first ever photograph, and the first time it was shown in stereo, the first ever photograph of a manned spacecraft over the surface of another world. This is the command service module of Apollo 10 with the moon in the background. Well, now we get up to Apollo 11, and this is, of course, one of the great iconic shots of all of the space program, and in this period in history, you could say, too, really. It's a boot print. It's not the first step taken by Neil, but it was one of Buzz Aldrin's boot prints, and we're showing it here in stereo for the first time. And here's an even more famous image. This, of course, is Buzz Aldrin. This is the most famous image taken probably of the entire space program. This is Buzz Aldrin as photographed by Neil Armstrong. And if you get up really closely and see in an enlargement the detail here, and maybe you can see it from there, you can see the reflection of Neil in Buzz's visor there. And that was not practiced that way. That just happened in that way and is really an iconic place. And this was shown for the first time again in stereo. Well, I think you'll hear from André about the incredible sensation of seeing Earth from afar and what that means to us as inhabitants of this planet. This is a shot taken from Apollo 11, July 17th, 1969. This is the first return mission, Apollo 12, and this is Alan Bean. Alan Bean took this photograph, and it shows Pete Conrad descending the LEM ladder just before he climbed down and uttered the legendary words, "Whoopee, man, that may have been a small one for Neil, but that's a long one for me." He was not the tallest guy in the world. And then near tragedy struck in the Apollo program. This is Apollo 13, of course. We all know about it. It's a very celebrated mission. They missed walking on the moon, Jim Lovell and his crew. An oxygen tank, which had been stirred, and a complex situation with it before launch, exploded and nearly cost the 3 astronauts their lives. As Jim Lovell likes to say, we almost became the first human popsicles in permanent orbit. That's kind of where the big news is with the Apollo missions, in the first landing in Apollo 13 and all that drama. But really, the science in a concrete way happened with the later missions, largely, because they were longer. They deployed rovers. You can see one of them here. And they collected many more samples. So what we learned about the moon, lunar geology, and the origin of the moon, which I'll get to in a moment here, largely came from the later missions, which are very interesting too. This is the most famous Apollo moon rock collected. It's called the Genesis rock. At first, it was thought to be an extremely ancient rock. However, it's not quite as old as the astronauts thought it might be because of its composition. It's about 4 billion years old. But the long story short, with the Apollo samples and with analysis of mostly of the flavors of oxygen locked up in crystals in moon rocks and in Earth rocks, the isotopes, is that probably the large impact hypothesis of the origin of the moon, a large body the size of Mars striking Earth long ago, throwing up a ring, accreting the moon, and a common origin of Earth and moon is how the moon formed. That's sort of the biggest idea that came out of the Apollo program. Well, of course, space flight and exploration is exceedingly dangerous. The crew of Apollo 15 left this aluminum sculpture that was made and left on the surface that was a memorial not just to the Americans, but to all of the space explorers of multiple nationalities, mostly American and Soviet at that point, who lost their lives in the business of being an astronaut explorer. So already then, when the Cold War was still going, when Apollo was still a young program, we had a brotherhood of astronauts of this nationality of the politics beginning to ebb away, and a sort of a vision, one vision of the astronauts working together beginning to take place. This is Charlie Duke saluting the flag on the moon during Apollo 16 in 1972. Again, these are just images that never have been seen in stereo. This is Gene Cernan now, the longest and most complex scientific mission, Apollo 17, the last, exploring the Taurus-Littrow Valley. Humans thus far have not been back to the surface of the moon after nearly 50 years. So we'll see how that goes in the future here. And it'll be interesting to ask André, I think, about his ideas about the future of exploration in our near solar system here. This I put in for Brian because his studies, as I told you, were about dust in the solar system. This is the zodiacal light. This is light from the sun scattering off of dust particles in the plane of the solar system, the disk around which the planets orbit, photographed by the Apollo astronauts. So that's pretty neat as well, I think. And then our book really isn't limited just to Apollo or to the 50-year-ago period either. We talk about the space station. This is actually Mir, the Russian space station here, but we talk about the International Space Station as well and others and show stereo images of them. Here we have Chris Hadfield doing his famous tribute to David Bowie with Space Oddity. This took place during his final mission in reentry in 2013. And then Brian, more recently, has been involved in stereo imaging, which is still a very great passion of his. When he's on tour with Queen, I mean, sometimes he's up in the middle of the night, you know, on tour, fiddling with these images. So he really loves it, and he's really into it in a detailed way. He was asked to join the New Horizons Pluto team and actually produce the first stereo views of the close-up detailed surface of Pluto as well from New Horizons. And just last month we were in Baltimore, and Brian was there again and was involved in the spacecraft's further exploration of a so-called Kuiper belt object, a distant asteroid-like body called Ultima Thule. You may have seen coverage on that. The brilliant Alan Stern, never one to drop the ball on publicity, scheduled that flyby for New Year's Eve and New Year's Day. So that was a good move by Alan, we presume. So, as I mentioned, the space race really began to transform even before the Soviet effort to land on the moon. And after Yuri Gagarin's death, by the way, it may very well have been our friend Alexei who would have become the first Soviet to walk on the moon, had that panned out. But even as the programs changed and we ultimately had American success, and remember they were not planting the American flag there as a nationalistic symbol, but as a world symbol there in the eyes of the astronauts, we had a transformation and a brotherhood of the space explorers that continues to this day. And there are very great bonds and friendships at Starmus and elsewhere between the Americans and the Russians and others as well. Collaborating and working on things together, which is nice to see, because now André can overrule me on anything I say about the space program, but I think it's probably true to say that going to Mars, if we take a next order of magnitude leap in the solar system, that's essentially going to require a multinational cooperative. That is breathtakingly more ambitious than lunar space. Anyway, this is, at the first Starmus, this image, this is Neil Armstrong and Alexei fraternizing and sharing stories of the old days and their first days in space exploration. Now, I was asked, forgive me, but I was asked to say just a little bit about myself very briefly here before I wrap up and we go to a little discussion. Well, who am I? Well, as I said, I was innocently minding my own business, working on magazines and projects, and at Starmus we thought, well, geez, we ought to do, Glenn Smith said, and you know, Robin said we ought to do a book on this kind of thing, and Robin said, well, you ought to write it, and so there we go. But I've been interested in astronomy and space for a long, long time, and I can remember staying up at age 8 very, very late in the Eastern time zone to 11 p.m. to watch the Apollo 11 moonwalk. That was, you know, really exotic in those days in 1969. But I got really interested in observing the sky when I was quite young and didn't become a doctor or a chemist like my father, but got into astronomy after I saw Saturn in a telescope at a star party in our town. And really was fanatical about it and got into writing about galaxies and star clusters and other things that are very distant, so-called deep sky objects that are much farther away than our solar system objects. And so started a little magazine It was really like a newsletter, and here I am covered with ink, producing one of the first issues of what was called Deep Sky Monthly. It coincided with, in the late 1970s and then 1980s, of astronomy enthusiasts having the availability of larger mirrors and larger telescopes for low cost. And so you could see all kinds of faint things like galaxies and so on much better than you could before. And so that magazine really took off and was quite a success. And so in 1982, I brought the magazine to the Publishers of Astronomy, the world's largest magazine about the subject of astronomy and observing the sky and also the science of astronomy. And we have about, I'm not trying to turn everything into an advertisement, but if you don't know what astronomy is, it's the largest magazine about astronomy and space in the world. It has about 100,000 print readers and then about 1.4 million digital circ and social media altogether. And so we have a lot of fun writing about all this stuff and space and galaxies and nebulae and planets and the exploration of the solar system all the time, and have for many, many years. And I just wanted to say, and I'll show one quick book to make this point quickly, and then I'll be done. The hobby of doing astronomy is in a relatively quiet period because kids are looking at their phone and they're not joining clubs and they're not doing things in the same way. Everything goes through this. And moreover, the hobby of going out and having organized clubs and observing the sky and so on really has been driven by bright comets more than anything else. We haven't had a bright comet really recently. However, that said, you know, it's chugging along just the way it is, and it's fine. We are in a golden age. If you're interested in space exploration and aware of space and the solar system, and not so much into astronomy, you ought to be aware we are in a golden age like never before in terms of professional astronomy, discoveries about galaxies, the planets, planetary science, cosmology, the origin and fate of the universe. There's so much research going on in those areas now by factors of several than before. So it's a very exciting time, truly, to be talking about, thinking about our place in the universe and reporting on it, because it is a land of riches, not just space exploration, but the universe, the cosmos at large. And we don't have another hour, or we could talk about some of these things, but one of the books that I've written, The New Cosmos, which Cambridge University Press published, talks about the 10 of the areas that in the last few years have really, really taken off. And some of those are big questions. You know, those are the age, the size, the fate of the universe, what will happen to life on Earth. You might not like some of the answers to those questions. Short answer to that one is within 1 billion years, we're all going to be gone on this planet. But we know so much more now about the universe, about our solar system, about our planet, and we really have to take care of it and work together on things, because there's only one place in the universe that we know of that can support us. And the distances are incredible, even in our solar system. You can't just up and move to a new place. So with that, I'll wrap it up. That's sort of a little bit of everything here, there, and everywhere. These guys might be coming to another place to speak near, especially if you're going down to England this week, near you at some point in the future as well. Brian's a great speaker. And we do have autographed book plates from Brian. I can sign books as well. And I think we're ready to move on. We have 6 or 8 other things to talk about here tonight, I think. Thank you.
So, you, David, are a truly multi-talented man, because if I understand correctly, you are also the drummer in the Astro Blues Band. Is that right?
Yes, I've been a drummer for, well, since I was 5 years old, I think. Can you hear me still? Here? Yes. So yeah, I like to play some of the rock and roll too. But our singer is not Freddie or Adam, so we're a little limited compared to Brian in that department. But yes, you got to have, as Brian has, you have that mathematical, the analytical part, of enjoying the intellectual, the universe, the why, we're here. You got to have the fun part too.
Oh, good. I'm glad Absolutely. It's all not just all hard work, although there is obviously plenty of that. You also do videos, you write a blog for the Huffington Post, you give talks, you do streaming videos, and next year you have another book coming out.
It's a book about galaxies, and galaxies are the basic building blocks of the universe. We know there are at least 100 billion galaxies in the universe, and if you go back in time, galaxies like to eat each other and to merge over time. Our Milky Way might consist, our own single galaxy, might have been as many as 100 little proto-galaxies to begin with. And you can see these little blobby galaxies in the early photos taken with the Hubble Space Telescope. Well, they come together by gravity and make bigger galaxies over time. And there hasn't really been a study of galaxies and what's going on in them, like big black holes and stuff like that, in a popular way in a generation. So that book is a big project that finally has come to fruition.
Is that part of the huge new wave of interest in space and space?
It's part of the huge scientific understanding of a lot of things that has really come into focus in the past decade or so, yes. Yep. Now we know, for example, that nearly every galaxy, except for dwarf galaxies, has a central black hole in the middle of this as an engine. However, don't ask about traveling through black holes because it doesn't really work. It's not good. Okay.
You don't come out at the other end.
Sci-fi stories are good, but you could come out in somewhere else in space-time, but you might be a 10-kilometer long string of spaghetti. As Stephen used to say, spaghettified. And then where you come out, it's not really a picnic. So we understand.
Have you been there?
No, no. But we understand a lot of that kind of stuff now that even really 5 or 10 years ago was much more hypothetical. Mm-hmm. Mm-hmm. So that's what that book is about. Yeah. It's, surprisingly enough, going to be called Galaxies.
Hey.
Brilliant.
Continuing on this riff of all the interesting and amazing things that you do, you also have a planet named after you.
A minor planet, an asteroid. Yeah,
I don't have any planet named after me.
Would you like one?
Sure, why not?
Okay.
Oh, I did my best. This is my planet shirt that I wore for you this evening. But no, I don't have a planet named after me, and I doubt I ever will. What is your planet like? Where is it?
It's a minor little, perhaps 5 to 10 kilometer diameter asteroid that's in the main belt. Most of the asteroids that we know of are between Mars and Jupiter. And it has no atmosphere, literally and figuratively. So even if you could get out to it, it wouldn't do you much. You can't retire on an asteroid, it doesn't work. There are practical problems there. The commute from the grocery store is terrible. So, but it's kind of fun because it brightens up enough that you can see it occasionally in an amateur telescope, and there you go.
And you say, there I am. Who named it after you? This was obviously a tribute.
There are actually tens and tens of thousands, and by now several hundred thousands of unnamed asteroids that astronomers have discovered, and they name them after people. And this was for doing this magazine when I was a teenager that I got some notoriety for, and so some astronomers at Lowell Observatory did.
What a compliment. Wonderful.
Well, thanks.
Yeah. Let's talk about the other stuff that we won't be talking about with André.
Yes.
So, John Adams, for example.
Yeah.
What's with John Adams?
Well, I've been interested in history for a long, long time, and ancient history, archaeology, world history, but American history too. And I've done some Civil War writing with my dad, which was because of an ancestor, and stuff that we got given to us from long ago. But I've really more recently gotten involved in studying the early presidents and the founding fathers back when they knew what they were talking about. No, I'm not.
Is this interest, does this interest date back 2 years or what?
So anyway, it dates back many years, but it's
Oh.
kind of resurfaced. And John Adams is a very interesting figure, of course, because he was such a tempestuous guy and the best attorney who was around during the early formative years of the United States. And in some ways very, very conservative philosophically, and in other ways evolved over time and eventually became
You
a
mentioned
Unitarian.
that his ideas, in many ways I've gathered he was quite straight-laced, but his religious beliefs and therefore his view of society became gradually more progressive as he moved on in life. He
That's right.
started out as quite a Protestant, Puritan, actually.
He started out as quite puritanical, and he always remained politically very conservative and pro-British, and not like those damned Virginians, who were pro-French, real radicals, Jefferson, Madison, Monroe, and that gang of troublemakers. But he became more religiously forward-looking, if you will, and eventually became Unitarians, the Adamses, and that was pretty progressive in his day, and eventually befriended Thomas Jefferson, of course, and as the famous story goes, they died on the same day in 1826, the 4th of July.
Yeah. Amazing, huh?
Yeah.
Amazing. Although they were also each other's opponents.
They had
couldn't
huge falling out for
Yeah.
many years, and arguably hated each other, and were political enemies for many years.
And Jefferson was a slave owner, and Adams was very much against slavery.
That's
so
right. And the Bostonians loathed it, of course, and the Virginians thought that, well, we can't do anything about this realistically in the Continental Congress, and eventually it'll just die out on its own. And then along came Eli Whitney and the cotton gin, and it didn't die out on its own.
Yeah. And then came the Civil War, of course, all about slavery, which is another of your interests.
Yes, yep, and that was because of getting stuff, just artifacts given to me of an ancestor who fought for Ulysses Grant and William T. Sherman, Tecumseh Sherman, during the war. So he survived and was a lowly private, but fought through the whole war and lived, and would sit in Dayton, Ohio, in his old age up to the point where he died in 1903, reminiscing about the war with a bucket, literally, of beer, dipping and drinking beer and asking the kids to go fill up his bucket of beer. And they said, "Is it true?" And as Darius Wetzel was his name, "Did you really go along and you were an engineer on Sherman's march to the sea and to Savannah?" And he said, "I didn't go along with it. I went ahead of Sherman and built the bridges so he could ride across," which may have been a little bit of an exaggeration, but that was the story he told.
By old age, it's okay to
That's
exaggerate a little bit.
Yep.
I wanted to come back briefly to something you mentioned in the book, and you also mentioned it again in your talk about the flag that the Americans planted on the moon when they first arrived. You say in the book, and you said again this evening, it was not a claim of the moon as U.S. territory. I'm sure a lot of people saw it as such. And then when we saw this image of the salute to the flag, I thought, are you sure?
Well, I don't know that Charlie Duke wasn't being ultra patriotic and nationalistic. Remember, the astronauts themselves, morally and politically and philosophically, spanned an enormous range, from Frank Borman probably being the most ultra-conservative guy you've ever met in your life, to Rusty Schweickart, who had the Dalai Lama go down and tour Kennedy Space Center, the hippie astronaut, Rusty Schweickart. So I think Charlie was pretty much of a nuts and bolts test pilot kind of guy in that way. But I think nationalistically for the United States, it was supposed to represent an exploration of a world by humans and not be purely we're planting this for the United States of America.
And they just couldn't think of anything else to plant other than an American flag. Is that it?
No, they couldn't. No. Now, granted, they did spend quite a few $1 billion and promised President Kennedy they would get there before the 1960s were out. But
Kennedy himself didn't make it, but...
No, he didn't, no. There was, with this movie, First Man, by the way, there was a huge controversy, in that they didn't show the American flag. And so a lot of people in the United States thought this was some kind of an international conspiracy, you can't win either way you go on some of these things, I think. You just have to let time pass and eventually education catches up with everyone. You hope, you know.
We hope.
Yeah.
Okay. For the time being, we'll leave it at this. We'll be back after André Kuipers has given his talk.
Excellent. Thank you.
André, the floor is yours.
Thank you very much. I'll take this one. Sure. So I will not show any pictures. I will talk about why we do this strange thing. Space is a strange place. We don't belong there. People are made for 1 times gravity, say 1 time atmospheric pressure, 5 kilometers per hour on the floor. If you go on sea, you already get seasick. And say 25 degrees Celsius. These are our specifications. So that means that we don't belong in space. We don't belong on a big part of our own planet. We're not fish, we're not birds, but we have brains. We can build ships. And actually, people are explorers. We conquered the oceans, we conquered the poles, we conquered the deserts. We can even go underwater, and even the air was conquered. And why do we do these crazy things? Why do people, for example, climb the Mount Everest? Well, the only reason why people climb a mountain is because it's there. There's no other reason to climb a mountain. But enough reason for a lot of energy, a lot of money, time, danger. Sometimes people do this because you want to be the first. Expeditions to the South Pole, people sometimes don't make it. Expedition of Scott to the South Pole, they were second. Amundsen was first. The way back they didn't survive. People are willing to risk their lives to go to places where we actually don't belong. But it can be a lot of other reasons. It can be the beauty of the underwater world, or a mountain landscape, or a polar area. It can be religion, or escaping for religion. It can be trade, of course, spices, oil, gold, power. All kind of reasons why people go to places where we actually don't belong. And science is also one of them. For example, the voyages of Darwin, of James Cook, went all over the planet. Also because the scientists in those days wanted to take some measurements of the Venus transit. Few times per few hundred years, planet Venus crosses in front of the sun. Pretty rare phenomenon. And they could make all kind of measurements from different places on the planet and then determine distance in the solar system. So a scientific reason to go to these places. When I was in the space station, we also had a Venus transit. So 250 years after James Cook, we could make this, take pictures of this Venus transit. So science as a reason to go there. And of course also, what we see here now, 50 years, prestige. It was, I mean, we wanted to go to space for all kind of reasons as well. The air was conquered and space was the next one. And people were dreaming about it a long time ago. People like Christian Huygens, famous Dutch scientist, described the rings of Saturn, discovered the moon Titan from Saturn. And he was already writing science fiction in those days. 350 years ago, he was already thinking, what would it be like to be there, to go there? Would there be other living beings? So people were thinking about it a long time. And for every big thing, you need 4 kind of people. You need dreamers, people who come up with a crazy idea in the first place. Then you need the thinkers, the scientists who calculate if it's possible at all. Then you need the people who make things, technicians, engineers, who build things. And finally also need the daredevils, people who are crazy enough to go into a balloon or on the water or step on a rocket. Sometimes it's in one person, but mostly there's ages between, because sailing ships in the times of Christian Huygens didn't work. Jules Verne was thinking of launching his crew as a cannonball. That's not compatible with life, that would not work. And we had to wait for Tsiolkovsky, Russian science teacher, who came up with the rocket principle. And that's nice, but then it's on paper, and then you need, of course, the engineers, Goddard, etc. Went very fast, because there's also a reason for these kind of adventures, military reasons. Black page in the history of rocketry is, of course, the V2. It was, I mean, von Braun might think of going to space, but it was, of course, a military weapon in the hands of the Nazi regime. And the Soviet Union and the United States quickly took this scientist over and to make rockets again, to throw bombs at each other. Well, we saw the history now that ended up with Sputnik, Laika, Gagarin, etc. And finally, of course, the highlight in spaceflight was, of course, the Apollo missions landing on the moon. Although I think that Apollo 8 is much more important than Apollo 11. Because with Apollo 8, it was the first time, we heard Borman's name already, with Lovell and Anders, first time that humans went away from the gravity field of our planet to the moon, and they saw something very special. And we see the moon rise, they saw Earth rise. Famous picture, and last Christmas was, of course, 50 years ago, the iconic picture of moonrise, Earthrise in this case. And that was very impressive because it was not meant. We went there for the moon, we went there for this technology. And of course, who was the best, who was the first. But the fact that we could look back was a very important moment. Because all of a sudden we could see, through human eyes, the eyes of the astronauts, that we all live on this very fragile blue marble there. And very limited, in a very dangerous environment. Space is very hostile. It's the emptiness, it's cold, radiation. The only thing we have is, of course, this planet, an oasis. And they call it then also, of course, Spaceship Earth. We are all astronauts on a spaceship with limited resources. It's very interesting to hear also the conversation of the astronauts inside from, oh, beautiful, take a picture. And it was not in the script. Nobody told them that that would be probably more important than all this technology. Now, there were all kinds of reasons to do this. And Apollo missions, prestige. Since then, spaceflight became very, very international. A lot of cooperation. All the small countries like the Netherlands and Denmark and Belgium, they cannot do space on their own. But together, for example, in the European Space Agency, you can do a lot more. And also, everybody uses space nowadays. If you navigate in your car with your mobile phone, you use your navigation satellites. You can follow all the ships, all the planes. They use it for precision agriculture. Navigation satellites becoming more and more important. Self-driving cars in the future, that's one form you use. Looking at the weather forecast every day, you use weather satellites. You can save lives to predict where hurricanes are coming. Very important form. Television report. What's happening in the United States? Well, it goes via communication satellites. 3 forms we daily use. Very important one, the 4th form, are the Earth observation satellites. With that, we watch our planet. Of course, espionage, but it's also used for agriculture. You can look in all kinds of wavelengths to your crops. You can even the wine farmers in Bordeaux, they use satellite information to see when you have to harvest your grapes for the best wine. You can find diseases in crops, food security. So agricultural sector uses it a lot. But also, for example, disaster organization. The Red Cross uses satellite information to assess the damage from an earthquake or things like that, or where flooding is going. And of course, our climate. All these discussions on the climate change, you do it with satellites. You measure the temperatures. You measure the disappearing of the ice, because with satellites around the poles, you can just measure it every day. Deforestation. All these things, I can see that also. I can see strange aspects in the forest, but I see it one moment. With satellites, you can look at it time and again. So after a while, you really realize what's going on. Air pollution, something that, well, you can see also with the naked eye. You can see these hazy layers over Chinese cities, for example. But with satellites, you can measure exactly what's in there. Very detailed. You can measure the difference between air pollution of the inner city of Amsterdam and the harbor of Amsterdam, for example. So we use all these satellites for all kinds of reasons that we have. And of course, that's 4 forms of satellites that go around the Earth. Then we have, of course, the explorers. That's more in the astronomy field. We send, of course, our probes into the solar system. We land on comets, and we go all the way to Pluto and beyond even. And then we have, of course, the 5th form of satellites, and that's the nice link with astronomy. The of course, the space telescopes. Telescopes who don't look down but look out, and we have Hubble is of course the most famous one, but we have of course in all kind of wavelengths we look into a universe, and that's what I personally look forward for in the future of that field is the James Webb Telescope, because I'm very much interested in exoplanets, and I would love to see the first proof that we can analyze the light of these exoplanets and get some more proof of life beyond our little planet here. But so far, we have only this planet. I was lucky to fly twice to the International Space Station. I did this because I got science fiction books from my grandmother, and I saw cars on the moon, and it was great. I mean, memory is a bad thing. You don't know exactly if I saw these pictures. Actually, in the Netherlands, it was not broadcasted as live, as I understood anyway. So you see it later, and you don't know if that was the exact moment. But I remember very vividly the cars driving on the moon. In the same time as the Thunderbirds were on television, for example. And science fiction booklets and radio plays. So that was the reason why I wanted to go to space. It was the adventure. What was one thing? Adventure, rockets. Space suits, aliens, etc. And then the space shuttle came. And then I saw these beautiful IMAX movies and the pictures taken from the shuttle, and I thought, whoa, it's not only adventurous, it's also very beautiful. I wanted to see the planet from space. And then I learned about space, what they did there, that it was useful, that you bring humankind a bit further with experiments, etc. So it was the three things. It was the adventure, it was the beauty, and the usefulness of spaceflight. And that were the reasons that I thought, okay, I'm going to try this. Didn't exist in the Netherlands in those days, didn't exist in Europe, but it became more and more possible, because in the cargo bay of the space shuttle was a lab, a space lab. That's from us, from Europe. So Europe could provide astronauts. And then there was all of a sudden a Dutch astronaut, Wubbel Ockels. Was not an American test pilot, it was a Dutch scientist. And he flew 7 days in the shuttle. I thought, oh, what's going on here? Maybe more important even was John Young. John Young walked on the moon, Apollo 16, and driving his car there. Probably he was the one that I saw driving him as a kid, and with Charlie Duke. And he was the first commander of the space shuttle, and he was sitting in the cockpit with spectacles on. And I thought, an astronaut is some kind of Superman. Astronaut's not Superman. You could be a Dutch scientist with spectacles. You could be a normal person. So I thought, oh, wait a minute, then I might do it as well. Well, it's not that you grab the phone and call order the next shuttle. It doesn't work like that. But it was a chance. So when the chance came, I grabbed it. And there was a long selection process, etc. And then finally, it's a long training process, and then when you are in space, it's not like you fantasize. It's like, everybody has a fantasy of being on a tropical islands and white sands, palm trees, beautiful. Reality is that it's very hot, you're burnt, you have sand fleas biting you, you're thirsty. The reality is always different than the fantasy. So in space, a lot of time in space, I was just busy and just working. In the first days, you're sick, you're space sick, you have fluid shift, you have a full head, it doesn't feel good, you have back pain because your intervertebral disc gets taller, and so the first days you think, what did I start here? And then it takes a while before you relax, and then look out the window, and then you, all of a sudden, you realize where you are. Normally not, especially not the first flight, because you're very busy, you don't want to make mistakes, everybody's watching you. So it's very stressful in that sense. And then you calm down, and you look out the window, and then I realized, yes, this is what I wanted. Now I'm in the science fiction booklets of my youth. And I flew over the Earth by night, and you see all these lights on the planet, and then it was like being in one of the novels that I read. And so then you realize I'm not part of it anymore, I'm outside. So that was a very special feeling. And you got two big feelings being in space. And one was, I remember very well, I flew over India, and I thought, wow, there's 500 million people living there. And they don't realize how small this planet is, because in 1.5 hours I see them again. And very thin atmosphere, as if you have the feeling if you blow very hard that you blow off the whole atmosphere. So it feels all of a sudden very fragile. If you look straight down to it, then it's majestic. Beautiful colors, turquoise waters of the Bahamas, red deserts in Australia. But as soon as you look beyond and you see the blackness of space, then it looks like the Earth is shrinking. That it becomes a living cell with a very thin membrane around it, as if it can, well, break any moment. So it feels very vulnerable for the dangers in space. A comet, asteroid can hit it. I also have an asteroid, and I always hope that it's not my asteroid that destroys the Earth. So it can happen. It happened in the past. So you never know. So it's very vulnerable, and that's one feeling that you think, oh, this is everything. So I call it a claustrophobic feeling. Not for myself. I was not afraid in space, but I got a claustrophobic feeling for the planet. So I thought, this is it. If we destroy it with atomic war, with a virus, or a climate disaster, there's no place to go. We grow every day with 200,000 people, every day, an extra city, like Eindhoven or Almere or whatever. Every day. So at least to stay in balance, you already have to launch 200,000 people every day. And then the question is, to where? There's nothing. I mean, to Mars? Well, very cold. Minus 140, no oxygen, no fluid water, no liquid water, no magnetic field, so a lot of radiation, an atmosphere of 1% pressure, CO2. You can go there and walk around as Matt Damon in a spacesuit, but that's it. It's not a place to go. Venus, closer than Mars, but it's, 500 degrees Celsius, 100 atmosphere pressure, and the clouds consist of sulfuric acid. So, not a place to put up your tent. There's no place to go. Maybe exoplanets, but the closest exoplanet, our fastest spaceship, takes 50,000 years to get there. So, maybe in the far future, in 1 billion years we have to go, but so we have time to develop something. But the only place we have here, and you feel that very well. So there's one big feeling, the fragility of our planet. And the second one is a cosmic feeling. Because I know that I live on a planet, on a sphere. But if I walk outside, the Earth is flat and the air looks endless. But from space, you really feel that you fly around a sphere. And you see Mars coming up and Venus. We had a comet during our flight. So just before the sun was rising over Australia, the comet came up. You see the moon and you fly under it again, etc. So you feel that you're part of something much bigger, that you're part of a solar system, of a universe. I call it the cosmic feeling. Religious people would probably say it's a religious feeling. Something that you're part of something much bigger than your normal life here. So these were, well, strong feelings that you have in space. Floating was very nice, the view was very nice, and I would love to go back. I will not go back anymore. But in the future, things will happen. We will use space a lot. Maybe we go later on with the questions on how we see the future. We continue, of course, with human space flight, but also with all these beautiful satellites and space telescopes that we're going to launch. We discover more and more and more about the environment. For me, the biggest question is there more life in space? I believe so, but we don't have proof yet. But I hope we find it on Mars, or maybe on the beautiful ice moons of Jupiter or Saturn, or in Titan. They're planning to launch a submarine to the ethane and methane oceans of Titan. Fantastic, it's like a science fiction film. Let's see, maybe there is other life. That would be a big thing. I hope to experience that moment. And then, of course, we will use space for planet Earth. For the energy, maybe we get, well, helium-3 from the moon. Harrison Smith is a big promoter of that, the Apollo 17 astronaut. Helium-3 could be a totally clean totally clean energy source for fusion reactors. Okay, we don't have that. Maybe it stays in the regions of science fiction, but it would be fantastic to have for 1,000 years clean energy for the whole planet. And maybe we're going to mine asteroids. There are several companies who want to go to asteroids, also to see how you can divert them, that our asteroids don't hit the planet. But it's full with yttrium, iridium, platinum, all these very rare metals that we have difficulty to find here on the planet Earth. So you might see mining in space. You might see for energy, for these kind of metals. So a lot of things will happen. Maybe tourism. There are companies now like Bigelow building, have big plans for space stations. Inflatable module. After my flight, they put one on the station. It's there for more than a year without leaks. This company wants to build a hotel in orbit around the planet. So maybe you can buy a room with a view. It sounds like science fiction, but the world we live in now is also pure science fiction for the people from not so long ago. So never say never. It will be different than we think, but there will be things coming that we cannot even think of. I think that's the best thing we learn from the past. Never say never. So I see a great future for spaceflight. We will use it. We have to be careful that we don't put too much garbage in space, that we have problems with space debris. That's our serious issues, of course. Expensive satellites, if they get destroyed, not to talk about human lives yet. So we will use spaceflight. I hope that we do this as an international effort. But I hope, indeed, that people will go to Mars for sure. I hope it will be an international thing. The United States, with Russia, with China, now separate still, with Europe, with Japan, that we do it as humankind. I don't think that will happen. I mean, it probably will be NASA with ESA, and maybe together with a private company like SpaceX. That would be a possibility. So we'll see. It might be that history will be first person in space from Russia, first person on the moon from the United States, and first person on Mars from China. Who knows? I don't know. It's very hard to predict the future. I think we can use spaceflight very well for our planet. We use it to watch our planet, to see what we're doing with this planet, and then it's up to the authorities to use their data. And not all authorities are willing to accept the data. But this is what we can do. We use spaceflight for the benefit of our planet and also in the future for other resources. And I hope we are all, preaching for the choir. I hope we can use spaceflight for the benefit of everybody and that we take care of this planet. Thank you.
May I ask Krijn Rijtsma to come on stage? Hello, hello. Welcome, welcome. This must be a very special moment for you.
Well, this is the first time the movie will be shown in public, basically.
Exactly.
And, well, it is Super 8, so it is 50 years old.
Yes, and you still have it. That's fantastic.
Yeah, but I had to have it revamped because it was on a DVD and it was very bad quality.
Okay.
But now, with all the technology, they are able to improve it to some degree.
Can we start the movie, please?
It may look halfway decent, but we have to see.
And if you sit here, then...
Ja, even kijken, we moeten even zien. Oh, daar komt het, ja, oké. Okay.
So tell us, you were in the U.S. to study. How old were you in 1969? Sorry, this is not ageism.
Well, this was in July '69.
Yes.
And
How old were you?
I was 25. And I was on the way, I was in Florida, on the way basically from New York to California to go to Stanford.
You were studying at Stanford?
I was going to study at Stanford, and I came from Cornell.
Okay. And what were you studying?
I was studying engineering at Stanford Business.
Okay. And this was something that, could anybody buy a ticket for this amazing event?
Well, I didn't buy a ticket, I got a ticket.
Oh, even better.
I had to solicit for a ticket,
You had to write a letter.
in Cocoa Beach. No, I went there personally, and I put on my suit in the big heat, because it was extremely hot in Florida in the summer. And so I put on a suit and I introduced myself.
And you said, I have to be a witness to this because...
and I would like, if possible, and so on and so on.
Yeah. And what was the reason that you gave?
But the reason was that I was an exchange student, and I was a guest in the country, and perhaps they would let me on the Kennedy Space Center for that event. And so a couple of days later,
were there other guests
I
as
got
well,
a call.
Craig?
Yeah, I was with my sister traveling.
But I mean, other guests, other.
There were lots of Americans later on. Yeah, lots of Americans that were allowed.
But how many
on the Cape.
how many guests were there at this event?
Well,
just the two
there must
of
have
you?
been no. There must have been 1,000. They were all parked on the road, with the cars, and it started at around 7 o'clock. You could go into the Kennedy Space Center at 7 o'clock with your car. You had to have a permit, and then you parked your car and you put in the chairs outside.
Oh, sort of like bermtoerisme.
It was, yeah, sure, absolutely. It was like that.
And you then sat and waited?
Yeah, actually, because the spacecraft was supposed to depart at around 9 in the morning, and actually it was 9:22. The pictures that you see here now, we made a couple of days earlier when we had a tour of the Kennedy Space Center, where the rocket was, on the launch pad.
How exciting. So tell me why you wanted to witness this in person. What did it mean to you?
Well, I didn't know what it was going to mean to me, but it was something very special, and it was quite clear that if you didn't take the opportunity, you would never see it again, presumably.
And how do you feel about it in retrospect?
Oh, I still find it absolutely fantastic. It's a very unique experience.
And was everyone jealous that you were there? Did this give you bragging rights?
Well, no, because I didn't show the movie in public. This is the first time the movie is shown in public. Yeah. And
why did you not show it before, Klein?
Well, why should I? Why should I?
It's such a Dutch answer. Because it's super special, that's why.
It is, yeah, it is, yeah, it is. But here we go. But there you go. And then you see the flaps going down, and everybody was shouting, "Go, go, go!" because it stands silent for a couple of minutes, and people thought it may fall down. And here it goes up. You will see after a while that the first stage gets dropped, and then a couple of minutes later you see the second stage being dropped as well. You'll see it in a minute when it's dropped. There it goes. There it goes.
And was everyone along the road completely silent, or was everyone shouting in
excitement? It was very silent. After the go, 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 they were very silent. Except for the fact, of course, that the sound of the rocket engines, was very, very heavy. It was a very, very big sound. So it's unfortunate that it is not with sound.
Well, I think it's still already very special, and it must have been. I mean, you really had the feeling that you were witnessing a special moment in history.
Absolutely, no doubt. Because a couple of days later in Key West, we saw the gentleman stepping on the moon. In Key West, yeah.
And have you followed the space program ever since?
Well, from time to time.
Okay.
From time to time. But I followed and André Kuipers his activities.
Okay.
Yeah.
And leading question: are you going to buy the book?
I may for my grandchildren because I have a granddaughter who is very interested.
Okay. Well, Krijn, the movie is almost over.
It's almost over. Yeah.
Is this the track of the?
There you see another stage. You see another stage going down. So and now it's all over because I couldn't, with a simple amateur camera in Super 8, you know, well, this is the best you could do.
Well, thank you so much.
Thank you.
It makes me feel part of it just watching this movie, being here with you. Thank you so much. May I invite David and André back to the stage? And I have just a couple questions. Of course, I have a gazillion questions, but I'm sure you do too. So I'll have two, and then I want to invite two other special guests onto the stage, and then we'll give the floor to you. I wanted to ask the two of you, in my introduction I said something about that contradictory spirit of, on the one hand, the space race being born out of competition in the Cold War atmosphere. The US thought, oh my God, the Russians are going to beat us, we'd better hurry up. Into this feeling of optimism and progress and the yes we can atmosphere of the 60s. How do you both see this? I can't resolve this contradiction in my mind.
Well, I think it was always fierce competition between the governments through that period and until Apollo's Soyuz. But I think what I was trying to say is that some of the individual astronaut explorers formed, if you will, something of a psychological brethren, even while the fierce competition was still going on. At least that's what they say now. So I think that's true, probably. And I don't know what you would, in more recent times, how you would reflect on that from a more intimate perspective, André.
Yeah, nowadays it's very international, of course. The International Space Station is built by all kind of countries that were fighting each other in hot and cold wars not so long ago, and now building the biggest technological project there is. It's a beautiful example how you can work together. I personally think that this is a very good candidate for a Nobel Peace Prize, seriously, to show how that you work together like that.
And so who should get that Nobel Peace Prize?
The International Station,
not a person?
It's a project. No, it's not a person.
Project.
It's a project. It's all these people working together, all these agencies working together. And of course, it's all non-military. You cannot do it if it's a military thing. It's science, it's technology, and all the cosmonauts, astronauts, it's all the same. We all work together for the common goal, for your job, your interest, the passion that we have. So we work together. You just don't talk about politics. So forget politics, leave the politics to the politicians. Hopefully it stays there and it doesn't go to the military. So it's all, as long as you don't discuss these kind of things, then it's great. It's all people, you talk about your families, you talk about your interests. I never felt that there was some political tension among the astronauts. We train in Russia, we train in Japan, in Canada, in Germany, United States, and also the Russians. Everybody moves everywhere, and it's a brotherhood in that sense. We're all in the same situation with the same purpose.
And how do you see the space program now that international tensions between the superpowers are growing by the day?
Yeah, well, that's not new. It's always going through history, and what you see that for us it doesn't matter. I mean, we are depending on each other. The International Space Station, the solar panels are on the US side, but the engines for attitude corrections and things like that are on the Russian side. You can only go there now with the Soyuz. So that doesn't matter what kind of tension there is, the Americans have to go with the Soyuz. The same for the Europeans and the Japanese. And then you see also, of course, okay, there's political friction, but also in sports. I mean, sport teams still go to Russia. That continues. Science, technology continues. And it's not new. I mean, in the old days, when the Netherlands was fighting wars with England, the scientists were just communicating, you know, about their stuff. So leave these wars to the admirals, etc. And that's good. I mean, let's start to keep on do the normal and useful things together, and just hope that it doesn't get out of hand. So because then you would have a serious problem. But so far it goes well, and I hope this continues. Yeah.
So we still have this healthy international collaboration, but some people say that the future of a lot of major forces for progress, such as the space program, are now in hands of private individuals, such as Elon Musk. They're the ones that have the power to decide, the power to invest, much more than governments. Are we privatizing the space program? David?
I don't think we are entirely. I think that's an element, and for a long time that was something, you know, it's sort of akin to scientific research by non-professionals. It was talked about like, oh yeah, that's really happening, and it wasn't. Now it's really happening in a legitimate and important way, but I don't see that, and again, Andre, you can weigh in a much more meaningful way than I can.
Is that a threat?
I don't see this as supplanting governmental efforts, though. Because, and in part, in my mind, because the scope of the goals in planetary exploration and in human spaceflight in the future are breathtakingly ambitious, as I see it, particularly a Martian mission.
Elon Musk is also breathtakingly ambitious.
But I think it's going to require monies and technology and intellect from both private industry and several nations to make such a thing happen. Maybe I'm wrong, and maybe it would be mostly NASA and Japan and Russia doing such a thing, but I see this being done in a robust way with a huge association of both governments and private industry.
Well, I think it's a normal process. It's a normal evolutionary process. You see the same thing with shipping, aviation. First, it's some daredevils who do things. Then, if it works, it becomes military. Then you start to do cargo, and then finally you have also tourism. And the same thing will happen with space. So that means that it's a normal process that private companies take over. And it's a task of agencies, of governments, to do the risky stuff. You don't do that as a company. But once that works, low Earth orbit, we know by now, well, that's very, very nice that companies take over. They do it probably more efficient. Okay. So that's good, you get competition. And then the governments can go on, do the exploration, back to the moon and to Mars, etc., until companies can take that over. Well, I think it's a normal process. Okay. And yeah, I think it's a good thing. Okay. And the combination would be interesting.
Well, my mind is at ease. I have two young guests that I would like to invite to the stage. Tijn, Sam. Hello. Yes, please. They're here with Tijn's grandparents, and they said they really wanted to come because Tijn is very interested in space exploration, but he wasn't sure he could follow the English. So how's it been going? Zeg maar in het Nederlands, hoor.
Wacht.
Kon je het volgen?
Nee.
Vind je het toch leuk dat je er bent?
Ja, dat wel. Okay. Ja, dat wel.
Sam, kon je het volgen? Hoe is je Engels?
Ik kon het wel heel goed volgen, want mijn ouders zijn ook Engels. Dus,
Kijk. Ja. En ik wist dat jullie ook in ieder geval wilden komen, ook al kon je het misschien niet helemaal volgen, omdat jullie heel graag deze beide heren een hand wilden geven. Dus ik wil je graag even die gelegenheid bieden. André Kuipers.
At least have some colors here.
We are friends, eh? We are friends. Okay, here you go. Thank you. Good luck.
Thank you, Tijn. Thank you, Sam. So, ladies and gentlemen, the floor is yours. It's on.
Thank you. We're all little kids when it comes to this topic. One question for each, if I may.
Can you move forward a little bit so they can see you in the
sure.
light? Yeah.
To David, with the principal laws of physics, physics tell us that all particles have always been there. When you merge things, the mass remains the same, meaning that all material has ever been here, always, whether it's on Earth or in space. How do you think our knowledge now and will develop towards religion? That's one, if I may ask the other one question.
Well, I'm glad we're starting with the easy one. Yeah. There's certainly conservation of energy in the universe, and we know that the Big Bang happened 13.8 billion years ago, and we know that mass and energy are conserved over time, and we know that the universe is expanding, and we now know that there's a universal force that is accelerating that expansion over time. And we know that there are at least 100 billion galaxies in the universe. It's at least 93 billion light years in diameter. And maybe, if you believe in cosmic inflation, which most all cosmologists do, we won't do a 5-minute sidebar on it, but look up cosmic inflation if you'd like. The universe could be infinite. So there are at least, at a minimum, of what we know about in the universe and can see and extrapolate through Hubble galaxy counts of ultra-deep fields, 100 billion galaxies in the universe, and there were more when they were smaller and didn't all come together, maybe 2 trillion originally. So
that must be a pretty thick book you're publishing next year.
Well, it's a lot of that's already in here. Yeah, but so there are, at a minimum, without cosmic inflation, 10,000 billion stars in the universe, and maybe a lot more than that. So to get back to what you were saying, André, about exoplanets, you can decide what conclusions you believe based on your religious or philosophical or scientific, however you want to phrase it, principles. I think it's breathtaking to imagine that we here are the only planet in the universe with sophisticated life, even. And what that means for you as far as our exploration going forward. I think life is out there. It's a lot of life, and a lot of it's probably microbial, but there are probably civilizations throughout the cosmos. The numbers are so big, but the cosmic distance scale is unbelievably huge. If this is the distance between the sun and Earth, 1 astronomical unit, then the edge of our solar system, the Oort cloud, is 10 football fields that way. And the distance to the nearest star is a lot farther than that. So getting there to other worlds is a big problem, even if there's a lot of life out in the universe, which I believe there has to be, essentially. And you can conclude what you think yourself, I think, about philosophical or religious ideas based on that.
I say, beam me up, Scotty. Yeah. Can I ask you to keep your second question till some others have had an opportunity? Thanks.
It's a big universe.
My question is directed to Mr. Kuipers. When you are in the space station, is every minute planned for work, eating, or sleep? Or is there any room for doing something that the spirit moves you? Do you play chess with the Russians? Do you read a good book before you go to sleep?
Chat with your nephew on FaceTime?
Yeah, something like that. Yes, we have a free time, of course. We work, say, 14 hours per day, and you have your pre-sleep and post-sleep periods, and you plan for the next day. But, of course, we do also things on our own. We installed a movie night on Friday. So we came together and we watched a movie. mostly comedies actually, to watch. We take some food. They send up whatever you want. So programs also. In programs they send up, you have your sports that's planned, but you can have some extra if you want. Looking out the window in your free time. There's free time. The Sundays are free. Saturdays are cleaning days, so you have to vacuum clean on Saturday, because in space you also have dust and skin particles and food particles, and it floats and it gets stuck on the filter, so you have to clean that.
Oh, hilarious! You have a little household up there.
Yes, absolutely. Saturday cleaning day. You have to get the coffee spots from the ceiling and everything floats.
You know, in my experience, Lemon Pledge works wonders.
Try it next time. So you have your free time. You talk with the family. We have, say, 70–80% of the time we have contact through the communication satellites, and you can call home. On Sundays we have 20 minutes of net meeting, so you can see your family and friends. And they have a camera at home, and we in the station, so you can have live
ET phone home.
Something like that. Absolutely. So we have our free time. It's impossible to work 24/7, of course. So and the most nice thing is playing with fluids that float and straight. I was flying with Don Pettit, very bright person, and he had fantastic experiments on this. So every time I was surprised what experiment he came up with this time. So very nice thing. So it was enjoyable. We work hard, but we also have some nice free time. Yes.
Thank you very much.
Hi.
You can take it out.
First, as a fellow alumni, I'd just like to say how cool it was to see Cornell Engineering represented on stage, so go Red. My question, though, I'd like to tie in a couple of your interests. During the Civil War, the Union troops were famous for trading their coffee for the Southern tobacco. I'm wondering what kind of black markets exist on the ISS similarly. Who's got the good stuff?
Well, there are some public secrets, of course.
Fess up, André.
Well, one of the things is that if you go to space, you bring something for your colleague astronauts. And you put that in your spacesuit. Because there are a lot of traditions when you go to space. And one of the traditions is, because Yuri Gagarin, well, assumingly had a full bladder, the bus stopped halfway. He went out of the bus and he peed against the wheel of the bus. So since then, every cosmonaut does that. That's a tradition. But then your spacesuit is open. Only outside. So in the bus, you close it again, and you could put some things in there. So my Spanish colleague put in some Spanish ham, so take something from your country. And I launched my first flight around Easter. So I thought I'd bring some chocolate Easter eggs. That was not a good idea. It's pretty hot in a spacesuit. So I had some contraband with me, but I could not present it anymore.
I'm just glad it wasn't bitterballen.
Go ahead. Hi.
Are human technologies ever going to advance onto, are humankind ever going to be on Europa, Jupiter's moon? And this question is to David.
Now, what was it again about Europa?
Are humans ever going to be on Europa?
Are humans ever going to be on Europa? Well, we hope that there'll be a mission within our lifetime and relatively soon to go and explore Europa. And I think it's very likely that if there are any microbes in our solar system, some might exist in the subsurface oceans of Europa. I don't know that it would be, we certainly could have a manned mission to go to Europa and explore it. It would be incredibly expensive. So it really depends on politicians and bank accounts and what they're going to fund. It could be done. It would be an exciting place to explore. I'm not holding my breath that I'll see that in my lifetime, a human mission there. But who knows?
There's a lot of radiation around Jupiter, so it's not a very safe place.
Yeah, thank you very much.
Thank you.
Good evening. One question for David. What would you think is the technological advance that we know of, say, nanomaterials, or other technologies that we know are developing that will contribute the most to space exploration in the coming decades? And if you have time, André, what is the worst thing about being an astronaut?
All that melted chocolate in your suit.
I think both of those questions would be better handled by André. I think you've worked very specifically in terms of what you see as the most important materials that have been developed from the space program in recent times. You're much better qualified to answer that than I am.
Well, actually, I'm not so sure. I mean, that's up to the scientists. We are just the hands and the eyes of the scientists. I did a lot of experiments. But if you do an experiment for fluid physics experiments for a Japanese professor, I'm not reading the Japanese fluid physics magazines. So I'm not always getting the data back. What we know, of course, from why we do space, I mentioned it in my talk, all these different reasons why we have it, the applications that we have, everybody uses it, but it's also innovation. So it's very difficult to build things for space. You have to deal with vacuum, you have to deal with vibration, acceleration forces, big temperature differences, plus 150 in the sun to minus 150 in the shade, higher radiation levels. So it's very advantageous for a country to be participating in space flight because of all the innovation that you get out of it. Then you have, of course, all the spin-off. Things developed for space find their way back to society, and that can be in software, it can be in materials, applications, all these kind of things. And besides of the experiments, I did lots of experiments. I can take some examples. I did. We do the kind of experiments you do in space are threefold. You have experiments that are for space itself. How do you cool a satellite? Which materials you use to protect against radiation, things like that. Foam formation in tanks in microgravity. That's for space itself. Then you have fundamental experiments. I had 100,000 worms with me for DNA research, and that made it to nature. So that was interesting research. If I recall, these worms lived 3 times as long. I hope that goes for me as well. I don't know. Or special, you can have, for example, little droplets of molten metal in a magnetic field. You can do very, very precise research. So, and then you have the third form, which is industrial. I did viscosity research for oil industry, crystal growth for pharmaceutical industry. I did an experiment for Philips, for the lamps. They had certain gas lamps, and they were discoloring. And they didn't know what the factor of weight was in the process, what happens there. So with the results of that, they could improve the production process. So these are all kind of benefits that find their way back to society.
Let me just add one really quick thing to get back to the asteroids just for one moment. If we look at terrible problems that we know as scientists exist and we're going to have to deal with, global warming, climate change, polluting our oceans with unbelievable amounts of plastics and so on, destroying species at will. One thing that could be on a much shorter, shockingly short time scale, that could be a major problem for technology and for our lives as we like to live them, is running low on so-called rare earth elements. And, you know, scandium and yttrium and other really exciting things like that. So, you know, again, asteroids may be a key place to find. There's not an inexhaustible source of rare earth elements that are desperately needed for medicine, for technology, for our laptops and so on. And so maybe extending what is a really shockingly short lifespan of hundreds of years in some cases left, supposedly, unless other deposits are found, of those could be an important aspect of space exploration in the solar system in the near future.
And the second question, is that the worst thing? Well, medically, it's not healthy in space. We get 50 to 100 times more radiation, and it damages equipment. The cameras, you see pixel damage on cameras. We had a short circuit. We lost 25% of our power because of a particle hit on the electronics. And you see it yourself sometimes. You have your eyes closed and then you see a stripe or a flash. Your retina is hit by a radioactive particle. So, and then we're still, because we're above the atmosphere, then we're still under the magnetic field for for travel to Mars, this is a big problem. You get a lot of radiation, so that's a serious issue. You get bone loss, so it's not that healthy to stay in space. And from a psychological thing, what I disliked most was the Big Brother feeling. You're living in some kind of glass house. There's always cameras. So whatever you do, there's cameras on you. Normally, it can be okay if your colleagues look and help you. But it happened also that I was one day floating through the US lab to my sleeping cabin. And I thought, let's give my nephew a call. So I went to my cabin, to the laptop, called my nephew. He says, oh, nice, I just saw you on the screen. I said, oh, which television program? No, he says, live on internet. Live on internet? And then I realized, oh yeah, NASA has the camera that they in the lab. Sometimes they stream it. The whole world can see you. And then you realize all of a sudden, oh, my shirt in my trousers, and am I still looking good? So then you feel watched, and there is a delay, because it happened once that the US astronaut came out of the airlock with his diapers on, so they could quickly switch off the streaming. But we decided, we agreed, okay, after we have a daily planning conference in the morning, in the evening, and after the daily planning conference, we switch off the cameras, so you can be more relaxed. So that I didn't think of that aspect before I went to space, that you can be watched any moment, from Sri Lanka, from Greenland, from everywhere.
Well, maybe
That's
if there's
big brother.
maybe if there's some financing problem, you could always have a Big Brother on the ISS to sponsor the things. Thank you.
Okay, thank you. Sure.
Yeah. I had this question for quite a while, actually, and you two are perfect for answering it, I hope.
You can take the microphone out.
Yeah, okay, I'll do that. Thanks. So 50 years ago, we landed on the moon, and there was a huge race to get there. But since that time, the past 50 years, we had very little activity towards going to the moon. I always expected, as a kid, that we want to go at least like once a year as humans, or have like a space base. I've had something like a space base on the moon, but there are no plans like that. I don't know if, especially André, have you ever asked ESA or NASA from like, hey, can't you guys send me to the moon? And they're like, no, we can't do that, or something like that. I don't.
Well,
yeah.
Maybe you should read astronomy, because there's several things going on the moon. I mean, there's now these nice Chinese cars, first on the front side, now on the back side of the moon. We have very interesting the Lunar Reconnaissance orbiter, which takes fantastic pictures of the moon. You can see that. What I like very much is all the tracks of the rovers and the landers of Apollo. You can see them with this satellite. So there are absolute activities on the moon. Well, what I said in the beginning, it was prestige. So there were plans for Apollo 18, 19, but it was very expensive, and they have to get money from the Congress all the time. So then they decided to do other things.
You don't think it's worth it then?
Well, it becomes worth it again, maybe for helium-3 mining. But also, what I would love is to it's 1/6 gravity. You could build a fantastic observatory on the moon. Yeah. So you can use the moon for scientific reasons. That we don't know everything about the moon yet. So there's a lot of reasons to go there for scientific reasons, for astronomy reasons, and maybe even for mining reasons. So it will happen, and we might have a new moon race. But China is interested to go to the moon, and maybe that's strategic. Yeah. So that would be interesting, because, well, from this story it's clear, if there is a political drive or a prestige drive, then things go fast.
Okay, we have 3 more
when
questions.
the situation comes down once again to my rocket is bigger than your rocket, it'll probably happen again.
Yeah. Hi.
Hi.
Can you step into the light, please?
Oh, is this good? Yeah. Okay. You talked about a number of different space missions. You talked about a possible manned Martian mission, space tourism, a manned Titan mission as well. I was just wondering, because there are so many potential directions that space exploration can go at this point in time, are there any that you personally would prioritize or would favor over others, or would just find, this would be really cool to do just for science reasons or personal reasons? Just, is there any particular direction that you would favor the current space industry to go towards at all?
To me first? I think probably, and again, maybe I'm wrong, you have more experience than I do, Andre, but I think probably to go onward to Mars, which again is going to be fantastically expensive and complicated, but I think it will happen, and it'll probably be a coordinated effort. You probably have to go back to the moon first again. So I'd like to see that. Now, again, Carl Sagan used to make the argument over and over and over, you can do, 20 times as much robotically as you can with human missions. I like to see a robust program of both, call me greedy, because I think so much comes out of a human spaceflight effort, both in terms of the human spirit and the reason why we exist, the fact that we're sentient and we're products of the universe. The heavy elements in our bodies, atoms, were produced in exploding stars. We're made of stuff made in the stars. And the fact that we're sentient, that we can think about that and talk about it here and think, what do we want to go out and explore this universe that made us, I think is beyond incredible. And you also get a lot from a human space program, including the ability to pull this out, which we do 157 times a day now, and lots of other things. So I think it has lots of benefits right down here on Earth. And I think we should also do robotic exploration like Ultima Thule and New Horizons and things like that. And if we have our priorities straight as a civilization, we can do both those things.
Well, what's very important is the time scale. If you look at 200, 300 years from now, you look back to this age, and then we only see Sputnik, Gagarin, Armstrong, first people on Mars. They skipped the station, that's totally normal. So in the long run, nobody believes that in a million years from now, people will still only be on Earth. So we're making the first steps. It's like standing with your toes in an ocean to be discovered. Because one reason we didn't mention yet, and that's also, I like that reason very much, Elon Musk uses that also. If you are a species that lives in one biotope, you're very vulnerable. If you are a mountain gorilla or a panda, well, they're only there because we like them so much, otherwise they would be gone. If you are a cockroach or a rat or a human, sorry for the comparison, you're everywhere. You can live in different biotopes, you're much less vulnerable. Now, Earth is just one biotope. If something happens with this planet, and that could be an impact, for example, then humankind is lost. So from a biological, evolutionary point of view, it would be very wise to be in different places. So that's one of the reasons to start with a colony on Mars. It will be very small because it's a very harsh environment. But in the long run, I'm talking about, say, 10,000, 100,000, million years, we will spread out. And even if we take 1,000 times that, we have a problem with our sun. We have to get we have to get away from the solar system. So that's far, far, far in the future. But this is the first baby steps that we make. The steps on the moon were the first baby steps.
That was a good question. Thank you. 2 more questions and then we'll wrap up. I have a practical announcement when we finish and then a word of thanks. Hi.
Thank you very much for your inspiring talks. As a female researcher and a scientist, I'd love to know some names of female space scientists and females that have gone to space that have inspired you as well.
Yes.
Thank you.
Well, a lot of them actually. I don't know them all. First one of course, Valentina Tereshkova. We have several cosmonauts on the Russian side, a lot on the US side. Sally Ride was the first, and we had Ellen Collins, first commander of the space shuttle. Peggy Whitson, first commander of the station. In Europe as well, we have several European female astronauts from the United Kingdom, Helen Sherman. In France, we had Claudie Agneray. That's a medical doctor, just like me. She also flew twice, just like me. And after that, she became a minister in the French government. So who knows what I'm going to do? So, and recently, Samantha Cristoforetti, my colleague from Italy. So it's a lot of female astronauts.
Has anyone particularly inspired you?
Let's see. Well, for me, Peggy Whitson was, of course, interested because he was a biochemist. The others were a lot of pilots. Oh, Helen Sherman was also a biochemist, by the way, a chemist at least. So for me, it was more important. It didn't matter if it was a man or a woman, but it was more important what's the background, because in the past it were all test pilots, you know, and then later on, nowadays test pilots is a minority. It's engineers, it's scientists, medical doctors, all kind of disciplines. So it was more that somebody from the life sciences, from biochemistry, could also do this. So that's fact.
Thank you. Our last question. Oh, it's from the grandmother of
Tijn.
Of Tijn.
Yeah.
Hello.
Hello. My question is for André. I'd like to know, how was it for you to readjust when you got back physically, because I already heard you speaking about radiation, and emotionally, because you were back among people, had space, other noises, and seeing other things, because I think it was 3 months you were up there?
That's 6.5 in the end.
6.5.
Yeah, I was supposed to go for 5, but a Russian technician, he made a mistake with the next capsule. He had to pressurize the lines with 1.3 atmosphere, and he made a factor 10 mistake. So he pressurized with 3 atmosphere. So the lines broke, and we didn't have a capsule for the next crew. So we were kindly asked if we wanted to stay 6 weeks longer. We didn't have a choice, so we had to stay. So I had to stay for 6.5 months, which was not a punishment. I loved it. The nicest pictures I took in the last 6 weeks. So it was great to live up there, and it's very pleasant to float. So when you come back, it's exciting to go back. The re-entry is the most exciting part of the whole mission. Not the launch, it's the re-entry. Because you have a speed of 28,000 kilometers per hour. You brought that speed in with a big rocket, but you don't have a rocket to take it out. So if you don't do anything, you keep on orbiting, you undock from the station, and if you have to brake with a little engine to brake your speed a bit. If it doesn't work, after 2 days your oxygen is gone, end of story. So that's the first exciting moment.
Living on the edge?
Yeah, we train a lot to solve the problems if that happens. Then, of course, then you get into a bit lower orbit, and then you descend from 400 to 100 kilometers. At 100 kilometers, you hit the dense layers, and then, like a duck on the water, you brake in the air. It's aerobraking. That gives friction with the air, and it becomes 1500, 2000 degrees Celsius. You see it becomes orange and pink, and you see the sparks and the flames along the window. You push to your chair. Half a year long, you have been weightless. And all of a sudden, you're 5 times your body weight. It's like several people sitting on your chest. It's hard to breathe, and with the flames along the window. So for minutes, you go through the atmosphere. That's the second moment. The heat shield has to hold. And the third one is the opening of the parachute, which happens at 10 kilometers altitude. You become very dizzy. This capsule starts to rotate, and your vestibular organ isn't used to anything like that anymore. So instead of 2 displays, you see 20 displays. It's an unpleasant feeling, but it's a good sign. It means the parachute is open, so it's a good sign. Okay. And then you hang, and then you brace yourself, and then there's a big hit on the ground. And then you're stuck there.
You land on the ground now?
Yes.
Not in water anymore?
No, the water the United States have a lot of water, 2 oceans. The Russians don't have so much water. So you land in the steppes of Kazakhstan. Well, desert or water is just as hard, doesn't matter. You land, but then they take you out of the capsule, but it's like that they take a bag of potatoes out, because you feel as if a big magnet is pulling you. If you pull your hand up, it's like a big magnet pulling you. If you turn your head, you get sick. You get earth sick. Instead of seasick or car sick, you become earth sick. You become sick of your own planet, up to vomiting, yes. So because your vestibular organ is totally confused. If I turned my head, it was like the earth was on an elastic band coming later or something. So that's why you see astronauts sitting with their head still, looking straight forward. You have floated for half a year. It's like laying in your bed for half a year. Normally, if you get up out of your bed, there's sensors here, your arteries, and they sense that the blood pressure is going down. So your heart starts to contract stronger. You didn't use that blood pressure reflex anymore for half a year. So it doesn't come back straight away. So as soon as you're on the ground, the blood just flows into your legs. You see astronauts being pale, and they have orthostatic intolerance. Astronauts faint very quickly. So that's why they are in the seat, sitting still, pale, looking straight forward. And if you turn your head, you get sick. So it's not very pleasant. I really thought that the rest of my life, I'm stuck here now. You know, something puts me down. I have an Italian colleague, and he said, my apologies for the words, gravity sucks. Literally. Because you feel stuck to the ground. It's very, it's not pleasant. And it takes a few days that you are nauseated, that you faint easily. If you lie in your bed, it's like your bed wants to eat you. You drop things because you think things can float. You have to be careful walking down the stairs because you think you can float down. So in the beginning, it's not very pleasant. And mentally, I did not end up in a black hole. People ask that. Het zwarte gat after your flight, the black hole. I have so many like this. I mean, it's very nice. I talk a lot about it. I still do a lot of things in space flight. So I still like it very much. It's not that things stopped. Of course, I would love to go back. But the chance is very small. Maybe as a tourist, but then I need a lot of money. So, but things will change in the future, and who knows? I will not be surprised if somebody.